Hi, this video is lesson 4, module 10. We're going to talk about percent yield. So I have an analogy for you. So when you make popcorn, in theory, like if I start with 30 kernels, I should get 30 to pop, but that never happens. So we can actually calculate percent yield by comparing the number of pop kernels, which would be our actual yield, over our theoretical yield, which would be the 30 kernels that should have popped. And then we just multiply by 100 to make that into a percent. So when we do this in chemistry, we want to kind of understand these two terms because these are the two things that are going to go into the formula that we're going to use. So theoretical yield is always going to be based on doing stoichiometry. So you will do stoichiometry to calculate and figure out what the theoretical yield is. The actual yield is going to be from the lab. So when we do a lab, it'll actually be our mass of the product that we get. And then if it's not a lab and it's a worksheet, it'll be given. So the formula that you should write down then is right here. So it is percent yield is the actual yield, what you really get in the lab, divided by your theoretical yield, what you get from doing stoichiometry. So if you remember the lab that we did with the lines on the test tube, at one point we had formed this copper to oxide, the black. This is a precipitate. So we could have filtered it out and dried it and gotten that powder, that solid. So it's possible that when we do calculate a percent yield, that we will get less than 100%. And you can see in the test tube kind of why that would happen. Some of it will stick to the sides of the test tube. If you remember your stirring rod, there's a little bit of chemical that's going to be lost and not make it to, like if we had decided to put it out to dry. So it's common to have percent yields less than 100% because you lose some of the product while you're transferring it to dry. It's also possible to have a percent yield that's greater than 100%, and that is because most of the time the product is in water, like this is in water, and we would dry it. And so depending on whether it had enough time or not, it might not be all the way dried. So the mass is greater than what it should be because there's still water in there. And one other reason it can be greater than 100 is if you, sometimes the product will react with something in the air and then form another compound. And that'll add to the mass of the compound that you're trying to figure out. So here is an example that we can do. So silver chromate forms when an excess of potassium chromate is added to a solution. So when you're doing a problem like this and they say excess, that means you can ignore that. That's your excess reactant. And then you can assume that your given amount of the other reactant, that you know that this is your limiting reactant. So when you see that, it just means it's not a limiting problem, that you can just use that beginning amount of that reactant. So we're going to determine the theoretical yield on the reaction. So if we have 0.500 grams of silver nitrate, we can, convert that to mole. And then I'll do that with you. And you can do it with me if you're watching the video. Let me just grab that. So silver is 107.87. So I get 169.88 grams of silver nitrate in a mole of silver nitrate. And then we're trying to figure out the yield. So always when we do percent yield, it's one of the products. So in this case, it's the silver chromate. So we're going to do our mole-mole ratio and convert So we're in moles of silver nitrate. So I'm going to put the silver nitrate on the bottom. And then I'm going to put the silver chromate in the numerator. And then lastly, we're going to need to do back to grams. So the grams of my silver chromate in 1 mole of silver chromate. So again, I'll calculate it with you. So silver is 107.87, and there's 2 of them, plus the chromium, which is 52, plus oxygen times 4. So we get 331.74 grams per mole. So then I can just calculate it, and you can see that my units, the grams of the silver nitrate cancel, the moles of the silver nitrate cancel, then the moles of the silver chromate cancel. And then on my calculator, I'm going to do 0.5 times 1 divided by 169.88 times 1 divided by 2, and then times 331.74. So when I do that with 3 sig figs, I get 0.488 grams in theory. So this is my theoretical value of what I should get. My actual yield is right here. So my percent yield then is going to be the actual over the theoretical times 100. So it would be 0.455 grams of silver chromate over 0.488 grams of silver chromate. And then we multiply by 100. And then sig fig wise, just keep your sig figs. The 100 would really have infinite sig figs. So you can see we have 3. So we should end with 3. So I think you get 93.2% yield. So the percent yield here is lower than 100 probably because some of that silver chromate was left over like in the container or on a stirring rod. So let's do another problem. This is the reaction that's called the Haber process, where you can take nitrogen out of the air and react it to form ammonia. So in this question, again, we have that excess hydrogen, which means that's our excess reactant. So when we use the 20 grams of nitrogen, we know that's limiting, so we know we don't have to do a limiting problem. The actual yield is given in the question right here. So that would be 16.67 grams of ammonia. Theoretical, we do need to calculate it. So using the molar mass of diatomic nitrogen, and then we're going to do our mole. So 2 moles of ammonia for every 1 mole of nitrogen. And then we can use the molar mass of ammonia, which is 17.04 grams in 1 mole. So then you can see, again, this is just stoichiometry. So my grams cancel moles, my other moles, and I'm left with grams of ammonia. And then my calculator, I'm going to calculate this by so when I calculate it, I get 24.3 grams of ammonia. So that's my theoretical amount. So then my percent yield is going to equal the actual over the theoretical times 100. So it's going to be this actual 16.67 grams over the theoretical times 100. So in this case, I'm going to keep the least amount of sig figs, which is 3, and I get 68.6% yield. And that is